Hi, and welcome to resultant force. Now, in this, it's okay, this concept here about resultant force, but some people find it pretty difficult, so hopefully this will sort it out. Now, in Key Stage 3, in Year 9, 8 or 7, you probably talked about forces being either balanced or unbalanced. And if forces are balanced, then it means that they're the same. The object will keep doing what it's doing, or will just absolutely keep doing what it's doing. If the forces, however, are unbalanced, then it will change what it's doing. That's it, really. Now, you'll need to be able to use these words still at Key Stage 4 here in your GCSE. They're okay. If I look at this picture here, the forces are unbalanced because they're different. So something will change. And what will happen? Well, if this one has got a bigger number, obviously this one wins and it will go that way. The rope goes that way. And I can work out the resultant force that will cause it to go that way. And it's just the difference between these two numbers here. So the resultant force between 400 and 300 is 100 newtons. As I look at it, to the right. So my answer would be the resultant force on this rope is 100 newtons to the right. And newtons is a measurement of force. For this picture down here, we have two dogs also doing the same thing. So it says here that one has got 600 newtons to the left and 700 newtons to the right. What is the resultant force and in which direction? Again, pretty straightforward. 700 newtons one way, 600 the other, therefore there's a difference of 100 newtons to the right. The right hand side will win. So let's have a look at maybe a bit more tricky examples. Here's a football. We can say, let's say that this goes 100 newtons. It's being kicked 100 newtons, but the air resistance on it as it flies through the air is 20 newtons. What's the resultant force? 100 minus 20 is 80. 80 newtons this way. So the ball will travel this way, forward, here, this way. Now this is where it might get a bit more tricky because you have to add up things. So I've got a driving force here of, let's say, 600 newtons. I'm making it up as I go along. 600 newtons. And I'm going to say that the air resistance hitting this van here, or Land Rover as it looks like, but I'm not allowed to advertise. Let's say that's 50 newtons. And then I'm going to say that the friction on the tyres, we're going to say, on this one is 20 newtons and on this one also 20 newtons. And they might say, what is the resultant force on this 4x4? Because that's politically correct. Now in this one, I've got to add up all the forces going one way first. So 50, 60, 70, 80, 90 going this way. So 90 going to the right because I've added them up. To the right as I look at the picture. The driving force this way to the left is 600 newtons. So it's easy to pie now. 600 take away 90 is 510. So the resultant force is 510 newtons to the left. It's going forwards. It's driving forwards. So it's as simple as that, really. What's I going to say? If any other words you could use for this, it's because it's going 510 that way and there is a resultant force, then this is unbalanced forces. This one also, unbalanced forces. If I change this to 100 newtons, I've now got balanced forces. That's it. Thank you.